All right, let's dive right into this explainer. Today, we're actually turning a totally normal Sunday morning errand into a total masterclass in physics. So, I want you to meet Leo. Leo is on a very specific and frankly kind of high-stakes mission today. He's hosting a massive summer barbecue.
Picture this. As he walks through the sliding glass doors of his local supermarket, he grabs an empty shopping cart. You know how it is? Without even really thinking about it, he just gives it this casual one-handed shove to send it gliding down the produce aisle. Now, because that cart is completely empty, that incredibly light push sends it literally rocketing forward. It quickly picks up so much speed that Leo actually has to break into a little jog just to catch up to the thing.
Okay, fast forward about an hour. Leo's cart is absolutely no longer empty. It's now loaded to the absolute brim with 3 heavy bags of charcoal, enough hot dogs to feed a small army, and, get this, an absurd 15 giant watermelons.
With his grocery run mostly complete, he stops for a quick second to double-check his shopping list, and when he's ready to move again, he gives the cart that exact same casual one-handed shove he used back at the entrance. But this time, the cart barely inches forward. In fact, it feels like it's completely glued to the floor. No way is that one hand doing the trick now.
Now, you might be wondering why we're analyzing this completely mundane struggle, right? Well, what's really interesting here is what's happening just beneath the surface. Without even realizing it, our barbecue host Leo has just perfectly demonstrated one of the absolute most foundational concepts in all of physics. I'm talking about Newton's second law of motion, which is famously expressed as the equation F equals ma.
Let's actually break this down and see how these 3 parts of that famous equation show up in the real world of the grocery store. First up, we've got force, represented by the letter F. This is simply just how hard Leo pushes the cart. Next is mass, or M, which is how heavy the cart and all its crazy barbecue contents are. And finally, acceleration, A, which is measuring how quickly that cart speeds up from a dead standstill. This equation, F equals ma, basically tells us that these 3 variables, they're completely locked into a strict mathematical relationship.
Section 1. Same push, different weight.
This brilliantly illustrates the math in action. You can really think of this first scenario as A equals F divided by M. So when Leo gave his standard push, which is our force, to the empty cart with its super small mass, it resulted in a massive burst of speed, right? That gives us a large acceleration. But when he applies that exact same push to the watermelon-loaded cart with its huge mass, the resulting change in speed is just tiny. The core principle here is simple, but honestly, it's pretty profound. The heavier the object, the more it actively resists accelerating. It literally fights back.
Section 2. Same speed, different push.
So what happens when Leo decides, you know what, he wants that incredibly heavy, fully loaded cart to speed up and glide down the aisle just as fast as the empty one did? Well, to get a large acceleration with a huge mass, the math says he actually has to multiply them together. A huge mass times a large acceleration, that requires a massive force. That casual one-handed shove simply isn't going to cut it anymore. To generate that massive force, Leo has to plant his feet firmly, lean his entire body weight against the handle, and just heave with absolutely everything he has.
The beauty of this law of motion is that it isn't just confined to whiteboards and boring textbooks. No, it's dictating the physical world every single time you run an everyday errand. So here's what I want to leave you with from this explainer. How are you going to test this relationship out for yourself? Seriously, the next time you're walking through those automatic doors to grab your groceries, try consciously adjusting the force of your push and the mass of your cart. Just pay attention to how it accelerates. Is the physics working with you? Are you stuck pushing 15 watermelons?